Hey, DroidCon. It's been a fantastic experience today. I mean, they've done a really great job with this conference. Really appreciate you guys coming to this speech. And we are going to take you along on a journey that we went through over the last couple years, and good and bad. Like, it was a roller coaster. We learned a lot along the way, and I want to impart some knowledge that we gained along that journey. So. My name's Thomas Wolf. I'm the head of Android engineering at SiriusXM. With me today is someone way smarter than me, Stu Horner, and he's one of the staff engineers on my team. We are part of the SiriusXM family. If you're not familiar with SiriusXM, it is the leading audio entertainment company in North America with over 150 million listeners. SiriusXM is known as the pioneer of satellite radio. And underneath the SiriusXM umbrella, we have Pandora, one of the pioneers in music streaming, specifically known for our recommendation engine called the Music Genome Project. And recently we brought to the family the Stitcher podcast, which is an international podcasting app. And I would be remiss if I didn't include our ad division, which is one of the leaders in audio advertisements. And this isn't a sales pitch. I'm not trying to sell you on our apps. The reason why I'm bringing this up is it plays into the storyline. So over the last couple of years, we've been trying to bring these companies together. We've been evaluating our tech stacks and figuring out similarities and differences and how we could come better together. And in this journey, we discovered there were more similarities than differences. But what are we trying to solve here? For one, unifying duplicate tech stacks. That's extra overhead that if we're doing the same thing, let's just work together. We also wanted to modernize legacy systems and support and have an architecture that supports all of our different brands. We didn't want to pigeonhole under one interface for our various brands. On top of that, users are expecting dynamic and personalized experiences. The expectations from the user has definitely increased over the years. We want speed to market. We want to build cool tech, and oftentimes we as engineers, we get stuck doing kind of the lame features that really don't excite us or the users. And so if we can increase speed to market, or the ability to develop faster, then we can carve out more time for the cool stuff. We also wanted a strongly typed design system. While these are unique brands, there are enough similarities, and they should be complementary to each other. And lastly, freeing up engineering resources. There's always more work than you actually have engineers to do the work. So what do I mean by comparing similarities and differences? So if you look at this blue circle representing SiriusXM, this purple circle being Pandora, and this yellow circle being Stitcher, if we start to compare what is the same and what's different, they're obviously very unique brands. If I was to tell you that we were one unified company, you probably wouldn't have known that. But the brand are standalone. They have their own user demographics. They are not one and the same, but they are complementary. But brand has to stand alone. Then content. There is a lot of overlap, but there's also a lot of differences. SiriusXM does live broadcast, whereas Pandora, it's on-demand music, algorithmically generated recommendations. And then Stitcher, you're talking about podcast content. But then also SiriusXM does podcasts, and so does Pandora. So there's a lot of overlap in content, but there are some differences. Then there's everything else. All the apps need authentication and entitlements and analytics, all of the things that build up most apps these days. And so there's a lot of stuff that we could share. But if you look at this Venn diagram, you see that brand was where we really were different. So as you can kind of read between the lines, we took on this mission of developing a server-driven user interface. And this is just a fancy buzzword, or better phrased, a design pattern or technique that allows us to have our servers manipulate the user interface or control the user interface. And this is merely through a data response. Not anything fancy. It's not magic. It's merely a data contract between server and client. Now, when I say server-driven UI, everyone has a different interpretation of that. There's various other apps out, probably even here at the conference, that have done this. And we all have our own definition. And really all that, going back to that definition, if a server is manipulating the UI of a client, it is server-driven by nature. So it's a spectrum. On one end of the spectrum, you could have Jetpack Compose or XML, and if you're changing out an image or text value, it's still by definition server-driven. Or we can go on the far extreme end of the spectrum and build a website, HTML, and use JavaScript framework 5222. So it's a spectrum, and that's where we struggled to figure out what was the right balance. So let's do a case study. We wanted to build a feature that we called Megastar Backstage Page. And this was effectively a landing page for mega stars. So Drake on our platform would have his own landing page with various content related to him. And we wanted to build this on both SiriusXM and on Pandora. Well, SiriusXM, our app was built with about 80% server-driven, and what I mean by that is like intentionally server-driven, not just accidental. Pandora, we had a feed, we have a feed on our For You page, and that's our recommendation page. So, if we look at them, they're architected significantly different. Well, if we look at this particular feature, we end up seeing that to build this feature for SiriusXM, it took a couple days with very little dev effort. Whereas Pandora, it took 2 months. Now you're like, 2 months for a landing page? Come on. Well, if we look at the development lifecycle, this isn't anything new to you guys, but there are a lot of different gates along the way, a lot of approvals that you gotta get through. So you have to get through QA, and then you have to go through the release cut, and then oftentimes ProGuard rips something out, and then your release builds are crashing. Eventually you get through QA approval, you submit it to the store. We have it a lot easier on the Google side of the fence than our Apple partners, but we still have to go through that store approval. And then we go through our ramping, and oftentimes during your ramping, you find issues, especially when you're dealing with millions of users. And you could eventually, have to restart the process all over again. So what we wanted to do is this magic box called SDUI that allows us to ship features without having to do an app release. At least that was our mission. Now, what is this limited to? This is really limited to visual changes and predefined functionality. You have to build in the functionality and then provide the toggles and mechanisms to reconfigure it at runtime. So you can't fire your engineers. And how we accomplish this is through components. Components are merely a contract between the server and the client on a specific UI layout definition. And so what this allows us to do is build in the Lego blocks of the UI and provide the attributes and the mechanisms that the server can manipulate. And each one of these components have a unique identifier. That allows server to say, hey, show me the media transport control bar Pandora version. And we're able to do that because it has a unique identifier. So when we started out this journey, we started analyzing the anatomy of our UI. We're like, how would this constrain our design team, our product team, if we took on this framework? And we found that we could describe our existing UI using a very basic hierarchy: page, container, item. Now, why we limited to a very constrained hierarchy is because finding that happy balance between performance and flexibility. If you allow endless nesting, you're going to get into recursion hell. So this allows us to have that performance, but also have flexibility. So, and also it nicely translates into clean JSON, page, container, item. But you're like, okay, that's great for a feed. How do you do a more complex UI, a full now playing screen? This isn't a feed. Feeds are easy. Well, that's where we get into templating or the scaffolding of the page. So I already mentioned the page container item, and the page container item, this can be sliced and diced in infinite different permutations of this. So it's really just an agreement between the server and the client teams on how you want to subdivide the screen. But at each layer is actually a component, meaning that each layer has a definition as to how things will map up. And so if you look at the page, we know this is a now playing screen, and therefore we know that the underlying containers are going to be in this particular arrangement. We don't know what's going in those containers, but we do know that this container or this component has these containers. And so as long as we provide the scaffolding, then we can just layer in the more unique elements, the more nested components. And how do we do this? Like, this is actually pretty simple. It's just data mapping. It's key value pairs. So if we look at our JSON, and we see two examples. These are tiles that you might see in one of the applications. Each one of those has a unique identifier: component, channel, tile, tall. And it may have various elements within that component, but those are not changeable components. The image, artwork, and the text boxes, those are actually baked into that particular component. And that's what makes this a unique component. And how that maps is at every level of our data payload, you have the identifier, but you also have various elements that are common in a UI. Images, text boxes, and other various widgets that might be in the Android ecosystem. And we're able to describe this very simply by doing just key value pairs. So now I'm going to take you down kind of a detour where we may have over-engineered this. So Android was already working on SDUI, and we had accomplished what I've described so far. Well, then the business is like, hey, you just built a flexible framework. Can we apply this to our automotive team? And our automotive team, I'm not talking about Android Auto. I'm talking about embedded head units. So SiriusXM is a huge player in the automotive industry. We work very closely with our OEM partners and car manufacturers to actually build SiriusXM into the vehicle. And if you're driving here in the United States, more likely than not, the vehicle that you're driving has SiriusXM already embedded into that head unit. So they're like, all right, our software development lifecycle is even harder than you mobile guys. We actually have to be certified by the OEMs. We also have to follow the Federal Highway Safety Administration regulations, and it is much more painful. So we're not talking days or weeks to ship an app. We're talking months, if not years, to get that certified. So it is a royal pain in the butt. So now we're like, okay, we have this server-driven UI framework. Let's apply this to the vehicle. But they wanted even more flexibility. Well, we ended up building our own custom markup language. And if you end up doing that, you're probably doing something wrong. Just going to warn you there. Because at the end of the day, this was never going to get certified. This was never going to get past certification. And so we built this complex system, and the project ended up getting canceled, never saw the light of day. Point being there is, your code isn't sacred. You're going to go too far. You have to be willing to adapt and iterate on your solutions. So don't ever treat your code as sacred. So we ended up building a rocket engine when we really only needed a car engine. Well, what's wrong with that? We have a lot of flexibility. Well, I do highly recommend, and this is coming from the manager side of me, make sure you're setting up checkpoints along the way. Make sure your engineers are happy, your product folks, your product partners are happy, and make sure you are analyzing, what's working, what's not working, and does it accomplish the mission, and does it achieve the goals of product and your ultimately your customer. So we did a retro at this point, and the good. Well, we did accomplish a dynamic, flexible system. We ended up building our own markup language, and it worked. It was highly, highly flexible. It was a great learning experience. We effectively built a web browser. But the bad, or manager speak, the less good. Testing was a royal nightmare. I have a lot of respect for our folks in the browser community because it is a very complex system to test. Now our clients weren't aligned. iOS was doing one thing, Android had this rocket ship that iOS did not do, and so we have this discrepancy between these two client teams, and then our web team is like, screw you guys, we're already server-driven. That now the developer experience just was garbage. The problem was that we ended up reducing output. One of our main goals was to speed to market. And that's because we built a proprietary system. And proprietary systems aren't bad, but there is overhead, and you have to be very careful and really consider when building a completely proprietary system. One of the main reasons is documentation. You can't just go to Stack Overflow. You go, how do I align this text value? Well, you have to know your markup language, and if you don't properly document, which most teams do not, you're going to be in a world of hurt. So always question yourself if you're going to go down the proprietary route. Onboarding was also a nightmare, and this goes back to documentation. I mean, onboarding is painful on a good day, but adding onboarding to a proprietary system, it takes 6 months to bring on a new engineer. It was awful. And maintainability and fragility. If people don't know how it works, if that one dev goes on vacation and is the domain expert of that one thing, well, now you're effectively stopped. You're blocked. And then performance, and this is where product came in. We effectively built a web browser, and there's a reason why we don't use web views. Like we are a native app, and so if you're going to add that level of flexibility, you probably should keep it native. So that's what ended up happening at this point in the journey. And then the refactor. And this is the word that senior leadership absolutely love. And so Stu and one of his peers, Simon, they came to me and they're like, Thomas, we hate this. We have got to change course. And so Stu, if you want to walk us through that.
For sure. So we knew something had to change. And the first decision we made, the easiest decision, was no more markup language. So we had written our components in this custom JSON. It was miserable to work with. It didn't even look good. So we knew we needed a new framework for our views. So you probably know where I'm going with this. New framework, Compose, or components, Compose. So Compose had recently had a V1 release, and it was just the best option. It had faster dev feedback, better theming, and it facilitated a better architecture with a unidirectional data flow. So speaking of architecture, our first attempt also had issues adding features. So our logic was either baked into the components or globally applied, and that made it hard to change. As multiple projects were working with the same components, they were stepping on each other's toes. So we decided we needed an MVVM framework. And we also wanted it to be modular. So we wanted to use the same tech stack for multiple apps. And we didn't want to, for example, build a network layer 3 times. We wanted to be able to reuse it and save some time. And modularity has other benefits like encapsulation and also consistency. So we wanted all of our brands to speak the same language, which makes it easier to build and gives us more signals when things go wrong. We know where to fix it. So you can't go crazy with modularity. There's also some drawbacks. The biggest one, I think, is overhead. So for example, if you have a bug in that network layer, now you have to check out a different repo. You have to get your fix in, deploy it, and then update the version in your client app. So 3 PRs instead of 1. So yeah, you can't go crazy with modularity, but it helps us be able to build quickly without sacrificing personalization. So I'm going to go over how we sliced it. I'm not saying that what we did fits for every situation. It depends on your product and requirements, but this is how we did it. So every brand has its own app. This isn't like white labeling the same SDK or the same APK. So we have a services library. So this handles API calls, caching, auth. It's how we speak to the backend. We have a design system library. So I think of this as UI Toolkit Plus because it has unbranded components and then a system of tokens for color, typography, sizes, whatever we needed. to be able to like personalize and stylize those apps per brand. So like, for example, if SiriusXM is all about Howard Stern, if we needed like some special Howard button with fancy animations, we knew we didn't want that in the Pandora app. So not all our components live in this design system library, but it's a system where we can build components in a standardized way so that if we do end up having to reuse them, it's really easy to move them around, move it into the library. Then we also had this library for common SDUI setup. So that's stuff like navigation, converting like the network responses to models that our design system could use, and like basic page templates. And then a bunch of other stuff. So the goal is for our SDKs to handle as much as we can while not limiting personalization and stylization. And again, this isn't one size fits all. So this is a diagram of how we did it. So in green is the client app on the left. In blue is the SDUI library. So we initialize it with this client UI provider, and that's where we pass theming, our custom components, page templates, all the client-specific UI. So we also pass a network config, and that's because the SDUI library uses the services library to speak to the backend, get data, translate it into models that the design system library can use, and then return a view. So what did the client have to do here? It had to provide components, had to provide theming, page templates, and some page view models, and that's it. So I mentioned page view models because this whole system uses MVVM. So I think we're all familiar with MVVM. In this case, the design system library is the view. So we want to be able to pass a model to the view and have it render it. So this is what our model looks like. We have a model per page, not for the full app. And we broke it up into headers, sticky at the top, footers, sticky at the bottom, and content in the middle. And they're just lists of component data, and component data is just an interface that represents a single component. So this is what our view models look like. So these would live in the client app. This is like an example for a browse page. They live in the client app, but they're used by the SDUI library through these interfaces. The most important one is this page view model interface. So the view model has this flow, which is how we publish updates we publish a model. It has this get component data, and that's how we handle translating data from the server to the component data that our design system can use. And then we have this on action, and that's where we do our event handling. So this really lets the client focus on what makes it unique, what we want to do, the business logic and the UI. So now we're going to go into a demo. So this is kind of a hard thing to demo. A lot of the exciting stuff happens at compile time. So I'm going to ask you to use some imagination here. But I'm going to walk through the progression of how we would build an app with these SDKs. So imagine your PM comes to you and says, we need a new app, we need a new brand, and we need it by next week. So first of all, you ask for a raise. Then second of all, you say, well, what do we have going for us already? So we have and we have our SDKs. So you go into Android Studio, you create your project, you end up with something like this. So that's step one. Next, you're going to initialize our SDKs. So I'm going to hit that, and we get this. So I call this the free state, because this is what we get for free from the SDKs. So we have some navigation at the bottom. We can switch tabs. We have a bunch of basic components, stuff like rows, blocks, cards. And we have a little bit of a loading screen. And there's also some placeholders. So at the top here, it says unknown component search header, unknown component artist card. So these would be the client-specific components that don't belong in the UI toolkit. So now we're going to create those components. So we implement them, we inject them, and now we can render them. So this is using Compose. So even though this is an SDUI app, we still have all the fancy animations, all the firepower that Compose gives us. So we implement this search header, we implement this artist card, and now it's starting to come together. So at this point, we're still using the generic view model for pages that we get from the SDUI library. Now we want to add some functionality. So we're going to add our own view model for this page, and that gives us access to the event handling and to the model for the page. So then when we receive like a click for this row, we can go ahead and add a footer at the bottom. In this case, like a mini player. So we start playing the station. So that's pretty good. Now we have our views, we have our functionality. Now it's time to add theming. So we take our colors, our typography, our sizes, and we just apply them, and there we go. Now we have an app. So see, we have some better fonts. We have sizes, things like corner radius, add some nice polish. Yeah. So you go back to your PM, and they say, we messed up. We built a music app. We were supposed to build a podcast app, and we also built it with the wrong brand. We were supposed to build a Stitcher app. So you say, it doesn't matter, no worries. You just switch out those colors, switch out your theming, change the data, and you get your correct app. So that shows how the client can focus on what makes it unique, the business logic, UI, which is conveniently the fun stuff. So that's it for our presentation. Thank you.